Hello and welcome to Relatable Code. In this video, we're going to talk about objects in Kotlin. So let's get started. So before talking about objects, let's see the problem that they solve. Suppose we have some global settings for our library application, like for example, an opening time, a closing time, and for example, whether or not it's a holiday today. Using our methods so far, the way we can do this is by creating a class, calling it library settings like that. And inside library settings, we define a, for example, val opening time equals, for example, 8 a.m. A val closing time equals to, for example, 6 p.m. and a val for is holiday, so that our customers can know whether or not today is a holiday for the library. Well, if we want to access opening time and closing time from anywhere inside our code, we have to create this library settings class, okay? Like this. So we write library settings dot opening time or closing time whenever we want to have a reference for that in our code, whether it's in our main function or in any other class in our code, okay? And this is fine. This works, but every time you want to access these variables, you have to create this class so that you can access them. Okay? This is not efficient. You have to create a new class in your memory every time you want to access fields that don't really change. Okay? And that's where objects come to help. If we refactor this class, we can, instead of writing class, we write object. And objects don't take parameters. Okay, so we remove that. And now, instead of creating this library settings class, we just reference opening time and closing time from this object. How does this differ from creating a class? Well, an object is like a class that gets created only once in your application. Okay, and you can use it wherever you want. You can use it in your main method. You can use it inside another function. Okay, you can use it inside a class if you want, like this. And you don't have to worry about memory with objects because, as I've said, they're only created once in the scope of your whole application. Okay? And it's managed for you, so you don't have to worry about creating it. As long as you define object like that, this object gets created when you're on your application. And you can directly reference anything inside this object, whether it's a variable or even a function. Okay? You can use both of these inside your objects, and that's basically it. That's why you need objects in Kotlin. Okay? Well, besides global settings, how can you really benefit from objects in Kotlin? Let's suppose for simplicity reasons, we have a class called user. Okay? This user is basically a customer in our library application. And we want to know how many users we actually have in our application. Okay? I've shown you how to create classes with constructors, which is the proper way of creating classes. But how can I know that this user is created, not regarding the fact, regardless of how it is created, which means regardless of which constructor was used to create it? There's a function in Kotlin called init, which is short for initialize. And every time a user class is created, whether with this constructor or with any other constructor like this, whether it was created with an empty constructor or with a name, this init block gets called. Okay, I'll show you how we'll take advantage of that shortly. So in our object library settings, we want to have a way to track how many users we currently have in our application or using our application, for example. Okay. Let's say we have our user count. It's an integer and it's initially equal to 0. Okay. And every time a new user is created, inside my init block, I can write library settings dot user count plus plus. Okay. And now let's create a few users like this. Let's create 4 and let's print out the total number of users we now have in our system. So we write print line library settings dot user count. Okay. Let's comment out our previous code so we don't have a lot of print line statements and run our function. Okay, I created 4 users here and I'm trying to find the number of users I currently have in my system. Like that. And as you can see, I now have 4 users in my system. And the benefit of having that count inside my object is now I can have access to this count wherever I want in my application, whether it's in my main method or as I've shown you in any other class or function. Okay. If this count were related to a class, that would become more complex. Okay, because you can't access that anywhere in your code, just as easily as having objects. Okay. Now, this is one way of dealing with variables like this, which are related to this class, which is user. Okay, you can have them inside an object, but Kotlin provides you a nicer way of dealing with things like this called companion objects inside your classes. I'll show you how they work. So instead of having this user count inside your library settings, you now have it inside your companion object. I'll show you what companion objects do in a little bit. And let's remove this. Instead of referencing the one from my object, I'm referencing this one inside my companion object. Okay, so now I can just replace library settings with user like that. And if I run my function, I will get the same result. Why? And why did I choose to have it inside my class after I just told you that things like this shouldn't be available just to this class? Well, if you place them inside a companion object, as you've seen here, when I tried to call my user count variable, I didn't have to create this user, okay, this user class. And that's because I accessed it without these parentheses, okay? When you see these parentheses, it means I'm creating this class, like I've done here when I created 4 users. But if I don't use them, it's as if I'm referencing an object, okay? It's true that our class or our user is a class, but when I define a companion object inside that user, I'm defining variables that are not related to any instance of this user. Okay, instead, they're available globally as long as I do user.user count. Okay, this is not related to an instance of user. This is an instance of user. For example, I may have here var name string like that. I can access this name from my user class when I create it here, like this. But if I do user dot name, I will not have a name. Okay, because name, as it's defined here, is actually tied to my user class. I can't access it without creating a user. But my user count here, since it's defined inside a companion object, I don't have to create a user so that I can access this user count. Okay, and I can access it pretty much anywhere in my code. I can access it inside this function. I can access it inside any other class I want, such as this class, for example. Okay, and the added value here of using a companion object inside the class instead of having this user inside the object is you now know that this variable is related to the user in some way, but it's not related to a specific instance of this user. Okay? So I really want you to know the difference between accessing an instance of a class which is created like this using these parentheses, whether it's an empty constructor or this name constructor. This is still an instance of a class. Okay? Meanwhile, if I access something in my class like this without using these parentheses, I'm not accessing a specific instance of my class. I don't care if this class is created or not, in this context at least. I only care about this user count inside my class. Okay? And just to review, I used the init function here because this block of code gets called whether you're creating this class with an empty constructor or with this parameter for your constructor. Okay? And I want you to know the keyword for these objects in programming in general. It's called a singleton. Okay? And it's called singleton because it only has a single instance in your application. And you don't have to actually create these singletons every time you want to access them, which is why they're called singletons. Okay, as we've seen for our object and our companion object as well. You can have this user count inside your object, but it's better to have it inside a companion object if it's related to some class in your code. Okay? Meanwhile, our global settings here were not related to a specific class, which is why I kept them inside this object, but our user count at the end is a count of our user class. Okay, which is why it's more preferable to have this user count inside this companion object, which is a companion object of our user class. Okay? Note that with objects in Kotlin, you also have the flexibility of having your vals as const vals. Okay? And the difference between a val and a const val is that a val variable is created at runtime, which means it's created after your application actually runs. Okay? Meanwhile, const vals are created at compile time. Okay, because const vals, they generally don't change in value. And vals don't change in value as well. But to note the difference between them, suppose we have a val here for our user. For example, age as an integer. Suppose we have a constructor here. Just for simplicity reasons, I'm going to create a default constructor so that we don't change these. With vals, here you can see we don't have to define a variable at runtime with respect to our parameters, for example, for our classes. Now, when I create a user, I can create a user with the age of 20. I can create a user with the age of 21, for example, any other number, which means val variables are not determined at compile time, which is before you run your code. Okay. Meanwhile, const vals are determined at compile time. You can't change their values whatsoever, and you can't initialize them at runtime. Okay, I can't use const vals inside my classes like this because they're only exclusive for objects. So why would you use these const vals? Because they're more efficient in memory. Okay, when you want to reserve a space in memory, uh, using const vals is definitely more efficient than using vals with respect to objects. Okay, because if you use a const val, as I've said, this value will not change and you can't actually initialize it at runtime, which means the amount of memory to allocate for this variable would be a lot less. Okay, which is why you should use const vals for those variables that you are sure will have this value. Okay, and in this context of classes, of objects, sorry, at least, using this val in this way will also not give you the flexibility of changing it. Okay, so if I write, for example, here, library settings dot, is holiday? Yes. I can change it because it's also a val, but it's a val inside an object. Okay, if it's a val inside a constructor, like for user, it can have any value. But if it's inside an object like this, I can't change it. So in this case, you will not see a lot of vals like this inside objects. Instead, you will see const vals a lot more often. Okay, because you can't change them anyways, and you can't initialize them from outside this object. Okay, I'm talking about vals. So that's why you use const vals in objects. Okay, that's in case you see it in the future, which you will. Okay, and generally in constructors, you will use vals more often. Okay, and that was it for objects in Kotlin. Okay, if you find this content to be relatable, please don't forget to leave a like and subscribe for future content, and I'll see you in the next video.